Hello, Calculus. It's going to be viewed here on Monday. This video should be viewed on Monday after class, so that's the 24th. And we will be finding the second derivative implicitly tonight. So I'll just do that by example, since you have a fairly good idea of what implicit differentiation is by now. So let's zoom in and out for a while. Alright, I guess that's fair. Alright, so the problem I'm going to discuss is x squared plus y squared equals 25. Now that should, you should know how to graph that without a calculator. It's a circle and the radius is 5. So, alright. It's my awful rendition of a circle of radius 5. So when you draw yours to look even like a circle, then I'm going to ask you to find the first derivative and the second derivative of this graph at the point 3 minus 4. So 3 minus 4 is probably right there. So let's say it is 3 minus 4. So I want the slope at that, so the derivative is the slope. So drawing a tangent line there, I want the slope of the first derivative, and then I will take the slope of the second derivative. Alright, so let me begin here where we can see implicit differentiation. With this one is straightforward. We get 2x plus 2y dy dx equals 0. Now we will move the terms without dy dx to the right. And divide we don't have to factor anything. It's only in one term. Divide to get dy dx. Isolate it. And simplifying, we get negative x over y. So I was wondering what the slope would be at the point 3 minus 4. So I put in a 3 for the x and a minus 4 for the y. So I'm going to get the answer 3/4. So my graph here has a positive slope. I can't tell that it's 3/4, but our math tells us it is. Alright, so now we're going to go on and do the second derivative. So we're going to start, before, let me go back up here and remind you of some notation. Y prime can also be used dy dx. That's another way of saying it. And y double prime has that funny notation with the 2 in between the d and the d and the y, and then it appears on the upper right of the x on the bottom dx. But that's just read the second derivative. But I want you to get used to this notation. It's quite common. Alright, so let's take our answer from the first derivative minus x over y. So that's the first derivative. And now I'm going to find the second derivative. So I'm going to take the derivative of this. I'll use the other notation. Alright, so we're going to do, it's a quotient, so we're going to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, clean it up a little bit on the top and we will get a minus y minus an x dy dx over y squared. Wasn't much to clean up really. So what do we do from here? The trick is, in the middle of our second derivative appeared a first derivative, but we know what the first derivative is because we calculated it right there. So in it goes. So then it becomes quite manageable. And we get dy dx is negative x over y squared. And when we simplify that, we have a negative y and now a positive in the numerator. We have an x squared over y and a y squared. So let's just algebraically mess with that for a minute. Is it too dark in here? I'm sorry, I have to work on that. Alright, so I'm going to give the numerator the same denominator, so I'll multiply this by y over y. And I get a minus y squared plus x squared over y squared. So when this is a fraction divided by a fraction, I flip the bottom and multiply. I get minus y squared plus x squared over y cubed. And with that, I think I have one error. Oh yeah, I see it. Did you see it as I was coming through? Somewhere I have a sign error. All right, maybe it's, no, negative, negative. These are both supposed to be negative, so up here, the bottom times the root of the top minus the top. Oh, there it was. This was a minus, way in the first step. All right, two hands up. So that created a plus here, and a plus here. And then we had a minus here, and a minus here. And now we can take that minus out in front just to be mathematically cool about it. These are equivalent expressions. All right, so and then I was interested at the second derivative at 3 minus 4. So I'm just going to put a 3 in for x and a 4 in for y. And when I get that, I get a negative 16 and a, well, I'm sorry, this negative's in front of everything. And 16 and 9 gives me a negative 25 and 64 on the bottom. So that's the answer. That's the slope, this curve's second derivative at this point. All right, so there isn't anything way out new. It was just using some ideas. We talked about second derivatives. We talked about implicit differentiation. So now we're finding second derivatives implicitly. All right, that's all for tonight. We've got plenty to practice on in class with our implicit differentiation. So have a good night. Over and out.